Today we're going to keep looking at quadratic functions, but today we're going to look at a different form. We're going to look at vertex form. In our previous lesson, we were considering standard form, and that is y equals ax squared plus bx plus c. So just a different way to write our quadratic function, standard form, or today we're going to look at vertex form. Same idea with our linear functions. If you remember, linear functions can be written in slope-intercept form. They can be written in standard form. They can also be written in point-slope form. So there's lots of different forms for linear as well. But for quadratics, we've got standard form, and today we're going to look at vertex form. So vertex form is y equals a times the quantity. So you have parentheses here, x minus h squared plus k. So again, a, h, and k will all be numbers. There'll be numbers in those places, and x and y will remain our variables. A does the same thing A did in standard form, and that tells you your direction of the opening of your parabola. So over here on the right, let's add that. So the direction of the opening, when A is greater than 0 or it's positive, you are going to have a smiley face parabola opening upward. And just like with standard form, when A is less than 0 or it's negative, that parabola is going to be reflected over and look like a frowny face, an opening downward. All right, the next thing is your axis of symmetry. Your axis of symmetry, we still write that equation x equals to get that vertical line, and that's going to be x equals h from our formula. Now, look at our vertex form. It is negative h, so make sure you use a opposite sign here. If the vertex form was something like y equals 3 times the quantity x plus 5 squared plus 2, notice our formula is negative h. So this would have been 3 times x minus a negative 5 to turn that into a positive there. So our axis of symmetry, just as an example, would be negative 5. So just use the opposite sign there. Our vertex. Now this form is called vertex form, right? And so our vertex is super easy. We are literally going to pull the h and the k value from that vertex form, and that is our vertex. So in the example that I made up in orange, as an example, the vertex would be that negative 5, still that same value from the axis of symmetry, and then positive 2. So you always take the opposite sign of the x value or the h value, and then you're just going to keep the k value. You don't need to worry about switching your sign on the k value when you're writing your vertex there. Super easy. So hence the name, vertex form. Okay, let's look at number 1. Graph the equation y equals 1/4 times the quantity of x minus 3 squared plus 1 on the accompanying set of axes. You must plot 5 points, including the roots. Remember, those are your x-intercepts. And the vertex. So kind of the same setup on Delta Math as we did on the last lesson. Let's start with determining that axis of symmetry. So all we have to do is pull out that h value from our function. We're working with y equals 1/4 x minus 3 squared plus 1. So that h value is going to be a positive 3. Axis of symmetry, x equals positive 3. You want to use opposite sign there. So I'm going to come over here, positive 3, draw my axis of symmetry up and down along positive 3. And then determine our vertex. We are going to take our h and k value to make our vertex. The h value was positive 3, using that opposite sign. And then the k value is that positive 1. So 3, 1 will be my vertex. 3, 1. And so to finish graphing it, what I would suggest from here is use your calculator, or you can plug in values for x and evaluate. For example, if you wanted to test when x is equal to 5 to create another set of points, you would evaluate and plug it in. Simplifying, I'm going to get 1/4. 5 minus 3 is 2, will be squared. I chose 5 because I knew that it would simplify really pretty, because 2 squared is 4. And so when I do 1/4 times 4, that's just 1 plus 1 will make 2. So I will have an ordered pair at 5, 2. I can go ahead and plot that. And we've talked about the parabola as being symmetric. So I would also have the point 1, 2. And so then you could keep building. You could find one more set of points. But like I said, I think the easiest thing is going to be for us to graph it. So let's grab that calculator. From our home screen, we're going to do a new document and we are going to add graphs. I'm going to graph y equals. I like to use that fraction boxes. You can get that from Control Divide. We'll give you your numerator, denominator fraction boxes where we can clearly type in a 1/4, arrow out of that and create some parentheses for x minus 3. Arrow out of our parentheses, square that, and then you want to plus 1. 1/4 quantity x minus 3 squared plus 1, graph it. We can go to menu, table is 7, that's split screen table, option 1. And you could just scroll through here on your table. Here's your x values in that first column, y values in the second column. So there's an ordered pair 1, 2, which is actually what we already plotted when we reflected 5, 2. In our table, we see our vertex 3, 1. Let's see what other good ordered pairs we have. There's a 7, 5, and the reflected one, let me scroll up here. Yes, -1, 5. So 7, 5, and -1, 5, I'm going to add to my graphs. So let's add 7, 5, and it was -1, 5. So here's our parabola. Connecting my points here, I'm going to get that nice curve shape of our parabola. And so we have completed graphing our vertex form. We did not have any x-intercepts or any roots on this one, but you did get a chance to see how to graph that one by hand. Moving down, we've got those multiple choice questions again, but this time in vertex form. And I wanted to remind you, you don't need to graph these. You don't need to throw them into your calculator. Just use what you know. First off, this first one, number 2, is a happy smiley parabola. So I know my a value is going to have to be positive. So let's go through here. It's not this second one. It's not this first one on the right side either. Those have negative a values and should be frowny faces, but we have a happy smiley face parabola. I also can take my vertex on my parabola here. This is 4, -4. Now remember, when we go to vertex form, it's y equals a times x minus your x value from your vertex form. So this is going to look like x minus 4 squared, and then keep the same sign, -4 for that y value of your vertex. So make sure you change your sign on the inside so it's not +4, that first answer choice, it's -4, this last one. Number 3, we can do the same thing. We've got a frowny face parabola, so our a value is negative. So going through my answer choices, I'm knocking out these 2 on the left because I need a negative at the beginning to flip that parabola upside down. I'm going to come and take my vertex form, find that vertex, -6, 2. So again, this would look like y equals ax plus 6 squared plus 2. You can almost write these yourselves. So you need that opposite sign that we have on this answer choice, the top right. On the second page of our notes, we are going to determine whether the quadratic function shows a minimum or a maximum. So remember, that's based on our shape, right? If it's a normal smiley face parabola, you're going to have a low minimum point. If it's been reflected and it's a frowny face parabola, you're going to have a high maximum point. So we're just talking about the vertex and then based on our a value. Okay, and then the rest of the directions determine that minimum or maximum value of the function. So number 4, f of x equals negative x plus 4 squared plus 3. You've got a negative right there. My a value is negative, which means I know my parabola is a frowny face, which means I'm going to have a maximum, right? So we are going to have a maximum. What is the vertex? Use the opposite sign for your x. This is -4, 3. And so what is that actual minimum or maximum value? We're dealing with maximum. This is going to be the y value. So let's take our y value here. It was 3. So if we were to actually graph this, that maximum is 3. And when you do use the y value, how high it got, so 3 is our maximum value. Let's try another one, number 5. F of x equals 2 times the quantity x minus 5 squared plus 2. Our a value here, this is positive. So I know this is just a smiley face parabola, very happy, and that would mean I have a minimum. So minimum or maximum? Minimum. That vertex is positive 5, 2. And then what would be that minimum value? The y. So if I was to graph this, where is it occurring? At 2. It's low at 2. So the last thing we're going to do on our notes is rewrite our functions in vertex form into standard form. So as much as I love vertex form because I can just pick out that vertex so quickly, sometimes rewriting it into standard form helps us graph it or answer questions. So number 6, y equals 1/4 times x minus 4 squared plus 7. Let's change it into standard form. And just to remind you, standard form looks like ax squared plus bx plus c. So the first thing we are going to do is follow order of operations. So we've got an entire set of parentheses, x minus 4 squared. What I want you to do is expand that squared. I want you to write it twice. So let's have y equals -4. I'm going to write it twice. X minus 4 times x minus 4, right? That's what squared means. Plus 7. So I expanded out that squared piece. Now I'm going to FOIL. If you remember, we learned to multiply binomials by FOILing. First, outer, inner, last. So I'm going to multiply those two binomials in there. So I'll have y equals, we still have -4. I'm going to have x squared, first terms there, x times x squared. Outer, x times the -4 is going to give me -4x. Inner, -4x. And last, the -4 times -4 gives me +16. The next thing I'm going to do is combine the like terms that we got when we FOILed those two -4x's. Let's combine those so that we get -8x. Now, don't get ahead of yourself and combine the 16 and 7. Don't do that yet because 16 is still in those parentheses that need to be multiplied with -4. So let's do distributive property. Multiply that -4 across -4x squared plus 32x minus 64. And then you can have that plus 7 there at the end. Yes, let's combine those. So combine those like terms, the -64 plus 7 is going to give me -57. And now it's in standard form. Y equals ax squared plus bx plus c, where my a value is -4, my b value is 32, and my c value is -57. So then I can use that to graph or maybe answer other questions. But there is our standard form from our original vertex form. Let's try number 7. Y equals 9 times the quantity x plus 3 squared minus 5. Let's do the same steps, starting with that exponent of 2. Expand that out. Write it twice. X plus 3 times x plus 3. Do not drop that squared in and call it done. Now let's FOIL. First, x times x is x squared. Outer will give me 3x. Inner will also give me 3x. And last gives me 9. Combine the like terms from that FOILing process in your parentheses to give you the 6x plus 9 and minus 5 at the end. Let's distribute across our parentheses 9x squared plus 54x plus 81 minus 5. And your last step, combine those final constants together as like terms to give you 76. So there is your standard form. Y equals ax squared plus bx plus c, where on this one your a is 9, your b is 54, and your c is 76. And you could use that to solve problems or maybe graph. But there is how you can change from vertex form to standard form. To go the opposite direction, it's a little bit trickier. If you're very curious, I'd be glad to help you. But guys, for the most part, we're going to use those Inspire calculators to help us the most that we can because they will be time savers when it comes to our EOC. So this is quadratic functions in vertex form. We had already talked about standard form. I love vertex form because the vertex is literally right there. Now remember to always change the sign when you're working with your H value, whether it's to identify your axis of symmetry or the X value of your vertex. Switch that H value from your vertex form. We looked at identifying the graphs in the multiple choice answers, identifying minimum and maximum. Lots you can do with the vertex form, guys. Practice that. Let me know if you have questions. I'll be glad to help, and I'll see you in class.